The CPU core has received the vector. Its current task, whether it's running your web browser or a background service, is instantly suspended. The CPU performs a critical automatic operation, a context switch. It saves its current state, the contents of its registers, the instruction pointer, the stack pointer, onto a special protected area of memory called the kernel stack. This is like putting a perfect bookmark in a book, so it can return later without losing its place. With the context saved, the CPU uses the interrupt vector number it received from the APIC as a direct index into a fundamental OS structure, the interrupt descriptor table, or IDT. Think of the IDT as the kernel's emergency contact list. Each entry in this table, pointed to by the vector, contains the memory address of the specific function designed to handle that exact interrupt. This is the interrupt service routine, or ISR. The IDT provides the direct, non-negotiable address, and the CPU immediately jumps to that location and begins executing the driver's code. We've reached the interrupt service routine. The ISR is now running, but it's running at a very high privilege level known as an interrupt request level, or IRQL. At this high IRQL, most other interrupts of equal or lower priority are masked or ignored by the CPU. This is why the cardinal rule of ISR design is to be fast. Its only job is to do the absolute minimum work necessary, like telling the network card, "I've got the packet, you can send the next one," and capture any critical state. The heavy lifting is offloaded. Before exiting, the ISR schedules a deferred procedure call, or DPC. The DPC is the second phase of our handler. It runs at a lower IRQL, specifically dispatch level. At this level, other hardware interrupts can now be processed, making the entire system more responsive. The DPC will do the slower work, like copying the packet data into memory buffers for the operating system's network stack to use. This two-phase ISR DPC model is a masterful compromise, ensuring urgent hardware needs are met instantly while preventing a single chatty device from monopolizing the CPU.